Hey, what's happening, guys? Mr. Ernst here. Mr. Moore has been taking the lead. Let me just get the camera set here. Mr. Moore's been taking the lead on our videos here over the last couple days, but he is about to have a baby. Tuesday, he and his wife are going in to do that, so kind of cool. We are picking right back up. Mr. Moore kind of walked you through factorials, so like that whole idea of 5 factorial being 5 times 4 times 3 times 2 times 1, and he also talked about summation notation. So this sigma notation should not be totally foreign to you at this point. And so if you'll notice on the notes, we only have that bottom little part. I'd show you a couple things on the calculator, and so I'm just doing it like this today. So to fill out that small box on the bottom of the last page there, if we are talking about series here, and really what I want you to think about is a series equals the sum of a sequence, okay? So a sequence is just a bunch of numbers like 1, 2, 3, 4. This is a series because 1, 2, 3, 4 is a sequence. If you add a sequence together, you get a series. So not terrible here. So let's define some things for you. If we consider the infinite sequence, I think this is a mistake on your notes, by the way. I think Mr. Moore just has a sub 1, a sub 1, a sub 1. Should say a sub 1, comma, a sub 2, comma, a sub 3, dot, 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 a sub I. This just means it's infinite. It's never going to end. That's the first term, the second term, the third term, and that would be the ith term or whatever the end is. The sum of the first n terms of a sequence is called a finite series. Okay, finite meaning it has a limit to it. It has a countable number of terms. The opposite of finite is obviously infinite, meaning going on forever. So it's called either a finite series or the partial sum of the sequence, okay? So again, when you see that word series, I don't want you to be confused. I just want you to think sigma, think adding together, okay? So it can be demonstrated as this. This is the 1 to the nth term of the sequence a sub I. So this would be a sub 1 plus a sub 2 plus a sub 3 plus dot 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 a sub n. Now n is some integer, n is some number, so that would be like the first plus the second plus the third plus the fourth, fifth, sixth, seventh, and let's say that n is 8. This would be just adding the first 8 terms of a sequence together, okay? The second thing here in that box, the sum of all the terms of an infinite. You can hear Reagan in the background. I'll bring her by and she can say hi in a minute. The sum of all the terms of an infinite sequence is called an opposite there, infinite series. And you might be saying to yourself, if there's an infinite number of terms, how in the world are we going to be able to add it together? We'll get to it, okay? So this is an infinite series. You can see this is from the first term until the infinity term, okay? AKA all terms. And so this is just going to look similar to that one. A sub 1 plus a sub 2 plus a sub 3 plus dot dot dot. This time it's going to say a sub I, meaning that whatever that last, there is no last term, it's just adding it all together, okay? So that takes care of kind of the notation part of it, okay? Let me grab a paper towel to erase that. Now, Mr. Ernst, some of what you just said made some sense, but you also were kind of talking in mumbo jumbo a little bit. I'm going to show you a couple of different examples, and a lot of it really is just recognizing that a series just means add a sequence together. Okay, so on the next part at the bottom of your notes, it says, given the series sigma I is equal to 1 to infinity, so this is an infinite series of 3 over 10 to the I, and it says find ... and letter A is the third partial sum. That sounds super confusing. All that means, third partial sum is going to be the first 3 terms. So literally, the third partial sum, I just was bending over to make sure that I was reading that correctly, is this sequence, or this series I should say, which is just adding a sequence, starts with the first term. Third partial sum means the first 3 terms. So this is what you guys were doing last week with Mr. Moore. So this means then, okay, I should write this out with proper notation of 3 over 10 to the I. This means first term is going to mean replace I with 1, 3 over 10 to the first, plus second term is going to be 3 over 10 to the second, plus third term 3 over 10 to the third. Okay, so we get 3 tenths plus 3 100ths plus 3 1,000ths. I could grab my calculator and plug that in, but I think you guys can all get some common denominators here. We're going to have to multiply that by 100. So it'll be 300 over 1,000. Plus multiply this one by 10. This would be 30 over 1,000 plus 3 over 1,000. And that's going to give us 333 over 1,000, which is 0.333. Either one of those would be an acceptable answer. Okay. Now, the second one says find just the sum. And we're going to talk later in the unit about formulas for how to find infinite sums. You can find the sum of something that's infinite. For example, I'm going to give you more than what you need here, but we're going to talk about convergent and divergent. Okay. I can tell you right now that you can add this up. Okay, what's happening in each of these terms? They're getting cut. Uh-oh. Should probably tape that up there. That's why this tape is sitting here, Mr. Ernst. You dummy. Each of these are being cut in half, but you can actually illustrate this right here. Okay. If this is just one whole sheet of paper, okay, that means that here is half of it, okay? If you cut the remaining bit left, that would be half. Cut that in half, you get a fourth. This would be an eighth. This would be a 16th, and so on and so forth, okay? Well, this is never going to end, and just like that, this would be a 32nd. I can keep cutting this in half as well. But the point being is, we said initially that this was how many sheets of paper to start with? One whole sheet of paper. Well, just like that, when I add a half plus a fourth plus an eighth plus a 16th, although this can keep getting cut in half and smaller, I know that that's going to add up to 1. 1 half plus 1 fourth plus 1 eighth plus 1 16th. If you keep cutting it in half, this number is going to get more and more insignificant, and that ultimately is going to add up to 1. We'll explain a little bit more about that later. For now, what we're going to do is we are just going to use our calculator to estimate. Fool me once, shame on you. Fool me twice, shame on me. Okay, so B, the sum, whole sum of this thing right here, okay? Which means from 1 to infinity. What I'm gonna recommend, what we're gonna recommend is that you just plug in a pretty big number. Instead of infinity, plug in something like, find the sum of the first 100 terms. Now you might be saying, Mr. Ernst, that's crazy. I am not writing out 100 of those. You don't have to, okay? We're looking for the total sum. We're gonna replace infinity with 100, another kind of big number, and then we're just gonna use our calculators, okay? The new calculators make it super easy to do this, okay? So what you are gonna do, let me see how close I wanna get here so that the camera does this justice. That's about right, okay? You are just gonna go to your math screen, okay? So math right there, which is a button that we are pretty used to using. And you are going to scroll down to the summation. I hope I'm on the screen. I can't see this. Scroll down to summation, okay? And just click on summation. And when you do that, it gives you everything that you need, okay? You're gonna just plug in X instead of I. But you can see up there that we want from 1 to 100, okay, of the term of the sequence 3 over 10 to the X, okay, just like that, okay, and that is going to allow you to find the first 100 terms. Your calculator says, nope, ain't doing it. Too much, overflow, okay? So we're gonna go and we're not gonna do the first 100 terms. Let's just jump to this thing and we will do the first 50 terms of 3 over 10 to the X. PS, I should probably use the fraction button here to make that easier on us. There we go, 3 over 10 to the X. Okay, so that's how you'd enter it. Okay, now when you hit enter, it gives us 0.33333333333. Okay, and so we didn't use 100. Calculator said, I don't like you, that's too many. We got 0.3333. I think they had like 7 or 8 threes in a row. Well, hopefully that tells you that that's going to be 0.3 repeating, which is equal to exactly 1/3. Okay. So if they're ever asking you for an infinite series answer, the sum of an infinite sequence, for now you're just going to take that infinity and replace it with a reasonably large number. In terms of that example, not only does it allow us to talk about that, but also the calculator piece. So last thing I want you to do is use your calculator, please, to just find for me, I'm going to make this up on the spot here, the answer to the series first term, not even first term, yeah, first term. First term to the 11th term of 3x squared minus x. Now that's something that you could do on paper. It would just be a pain. You'd have to find 11 terms together. It's also something that Mr. Moore showed you how to use a couple of those properties to find. All I want you to do is plug it into this, okay? So go to math, okay? Scroll all the way down, go to summation. It's gonna give you that whole block. Plug in x equals 1. Up top we've got 11 there, And then our sequence definition is 3x squared minus x. Bam. Just hit enter, and hopefully you got 1,452. Okay. You're gonna have to do a little bit of both, with and without the calculator. You know, on series, using summation notation, but knowing how to do it in the calculator, pretty easy math, and just scroll down until you see summation. So, okay, hopefully that helped. I have, you know, office hours on Zoom. Miss Fulling does too. Mr. Geschwind is going to be jumping in for Mr. Moore. I'm sure he's already communicated all that to you, but Miss Fulling and I are also super available and more than willing to help you guys out. With that, good luck, Mr. Moore, if you're watching this. Hopefully everything goes as smooth as possible. Happy Easter, guys. It's Sunday. And hope you're having a good one with your family. All right, see ya.